Now let's hear from a real live customer, a Mumbai local CleverTap, who's doing some really clever things with containers on AWS.
Hi, my name is Francis. I run the systems engineering team at CleverTap. We are a powerful mobile marketing solution that helps growth marketers. And we help by building long-term brand loyalty with the ability to innovate, experiment, and build a sustainable competitive advantage. Just to give you a sense of our scale, these days with the whole IPL and the cricket going on, we do about 3.5 billion events in a matter of about 4 or 6 hours, whatever the range of the match is. What you're seeing is the numbers reported by the ELB. So it's about 7:59 in the evening, and we are at about 5 million HTTP requests per minute. And then a couple of minutes later, we are down to almost what looks like 11 million, and then it's all spiky from there, depending on what part of the match you are and how the match is going on. All this runs obviously on AWS. They power all of this infrastructure. We don't have to worry about bandwidth, capacity, ELB capacity, throughput. And the other graph that you can see is an internal metric of the split of traffic across customers. So we kind of ingest traffic, different times of traffic for different customers at different points in time. So there's the customer with the match there, and there's another customer who's randomly done something, and then there's another spike. So we have this all day, and it all just works for us. But I want to talk to you about how we use ECS. When you think about ECS, mostly it's all about stateless services or batch processing, where you bring in some data, you work on it, you process it, put it back into some persistent storage. But our use case for ECS is slightly different. We use it for stateful workloads, and here's why we do it. We have custom in-memory Java database that stores all of this data that we're ingesting. And this is what powers our analytics and engagement platform in almost near real time. It's in Java, for good or for bad, but it does memory management and garbage collection, which is why it was our choice. It's also fairly easy, I think, to hire Java devs in Mumbai. It's not very, but yeah, you can find decent Java devs in Mumbai. The problem that we've got here is that we're storing all of this in mem, 100%. And what happens is that when you run out of the amount of memory you give the JVM on an EC2 host, the only option that we had is to double the instance size. Doubling the instance size meant we get 50% extra capacity, but we also inherit twice the cost that we require now to service the customer. So we've got this 50% idle capacity just sitting there, and we're paying 2x on behalf of the customer. So our fix was to go with ECS, where we run these stateful databases on one single larger ECS host in a way. So instead of having to go from 128 megabytes to 256, we can be on a large box of 512 or a 2 terabyte. And then for that specific database that's mapped to a customer, we can just increase by 10%. And what this has translated for us is that we've been able to get 40% cost savings, just because we're not doubling instance types in a way. For every time we need to just increase it a little bit by 10%, by 20% for a given customer. And how you do this, how you give a container the identity of what or who it is you essentially add this attribute called ECS instance attributes. It's just a JSON format of key value pairs where the tag is, in this case, is called cluster.instance identifier. Can be anything, but we just call it like this. And its value is set to what looks like the cluster ID. That's the first part of the long string that you're looking at. And then you mash it up with the EC2 instance resource from CloudFormation. And this gives you identity in a way to specifically identify one single EC2 host that you can then map to run containers on. That's 50% of the work. The other half is to just point a task, which is a container. A task is actually just a container in ECS land. So you point it to run only on this specific constraint where the cluster identifier is set to whatever you want it to be, where your data resides. And that's how you kind of make this whole big thing stateful. You make sure that it only runs on the host where it's supposed to be, where its data is expected. And you don't randomly run off on some host where you have capacity. So to put all this stuff together for stateful workloads on ECS, what you do is you take a task, you sort of model workload into a task definition, your application who is stateful into a task definition. Task definition is wrapped around a service, and you just set the value to 1. The service can only run one task of this task definition. What the service does for you is that it also helps you monitor the state of this application. So what you can do now is you can monitor it running a command inside of the task or the Docker container. This command that you execute, you tell the service to monitor, can be anything arbitrary, which means you can essentially do stack traces or log collections. You can do stack traces or log collections just before you declare the service is dead. And you can take these stack traces, these logs, application errors, ship them to Slack, ship them to whatever your internal team communication tool is, and it's suddenly available to developers. It's suddenly available to everybody. You don't have to go SSH or go look for them somewhere. And that's quite interesting. The other thing it does for you, obviously, is that you don't have to wake up in the middle of the night to restart your service. So it's kind of auto-healing. If it goes down, it comes back up. No more waking up at 3 a.m. in the morning. What we've learned along the way is that when you're trying to do something like this, you should do it with CloudFormation and version control of those settings, because you have a lot of stateful mappings. This path on a EC2 host maps back to this task definition, things like that actually give it its stateful nature. So if you have no way to version control this, what happens is that you can lose track and you don't know what changed, and you find yourself with the application running on some random EC2 host where it doesn't have the data it needs, and that does not go down very well. The other thing that is to understanding with ECS is that once you register an EC2 host with ECS as a container instance, you cannot change its instance type. So in our case, we're used to going from 16 gig to 32 to 64 and 128 and so on. But you just can't do that once you register this as a container instance, because if you do change it, then the ECS agent comes back telling you that this is not the instance type. Either fix it or deregister this instance. If you're passionate about systems engineering, automation 100%, version controlled, auditable infrastructure as code, please drop us a line. I would love to hear from you. We are available at jobs at CleverTap, and we are based out of Mumbai. Thank you.